Subscribe to my channel and press the bell icon. Hello everyone, welcome to my channel on Learning Field. Today in this topic, we will learn how to derive potential energy of a system of two charges in an external field. To prove this relation, first of all, let us draw the diagram. Suppose this is a rough surface of charge Q1. Let this point be named as A. Suppose another point charge, that is Q2, is at B, point B. So the distance between Q1 and Q2 is R12. So let us consider that this is the first case. Let Q1 be the charge. Let Q1 be the charge present at the point A, due to which we get, let Q1 be the charge present at the point A, due to which we get an electric field. We get an electric field. Since our topic is to find the potential energy, since we know that potential energy is denoted by U, isn't it? We need to find the potential energy of a system of two charges, Q1 and Q2, in an external field. This is an external field of rough surface. So first case, we have considered that Q1 is the charge at A and Q2 is the charge at B. The distance between them is R12. So we have written then electric potential at B due to Q1 is. Now look here, there are also some electric field, isn't it? Therefore we need to find the electric potential at B due to Q1. Since from Coulomb's law we know that by finding the Coulomb's law we have also done the same thing, isn't it? So electric potential at B due to Q1, electric potential at B due to Q1 is, since we know that electric potential is denoted by V. If you don't know the formula, you can note down. Since we know that electric potential V is equals to 1 by 4 pi epsilon naught into Q by R, isn't it? This one we know the formula of electric potential. By applying the formula here, since we know that V is equals to 1 by 4 pi epsilon naught into Q. Now here the point R is denoted as R12. The distance is R12, isn't it? So we need to write R12. And the charge is Q1. So we need to write here Q1. Since we are going to find electric potential at B due to Q1, isn't it? That's why we need to write here Q1. Next, we need to find potential energy of Q2 will be. Now, the potential energy of Q2, since we have find the electric potential that is denoted by V, now we need to find the potential energy. Potential energy, comma U. Potential energy is always denoted by U. Since we know that there is differences between electric potential and potential energy. Electric potential means what? V, and potential energy means U. So U is equals to, that means of Q2. That means we need to find of Q2, isn't it? So UQ2 will be equals to VQ2, isn't it? Since we know that potential energy is equals to electric potential, so we can write potential energy of Q2. Potential energy of Q2, UQ2 will be equals to VQ2. So we can write here, since what we know that V is equals to 1 by 4 pi epsilon naught into Q1 by R12. So we need to substitute here 1 by 4 pi epsilon naught into Q1 by R12, and the additional term is Q2. So we need to write here Q2, isn't it? Now, therefore, we have find the potential energy of Q2. Now we need to find the total potential energy, isn't it? Since the question is that the main topic is that the potential energy of a system of two charges in an external field. So we need to find the total potential energy. Therefore, the total potential energy of the system will be U will be equals to UQ2. Now look here. We need to consider second case now. Second case. Since we know that this is the point A of charge Q1 and another point is drawn here with charge Q2 at point B, and the distance between them is R12. And now we need to consider another charge. Let the another charge be Q3. Let this charge be Q3. Now distance between Q2 and Q3 will be R23, and the distance between Q1 and Q3 will be R13. Since we know that it is about Q1 and Q3, so we can write R13. Before we have written that Q1 to Q2 is R12 and Q2 to Q3 is R23. This is the second case. Now, to find the total potential energy of the system, we need a third case, that is Q3, isn't it? So the total potential energy of the system will be equals to U is equals to UQ2 plus UQ3, which is equals to, since we know that UQ2 is equals to what? 1 by 4 pi epsilon naught into Q1 into Q2 by R12, isn't it? 1 by 4 pi epsilon naught into Q1 into Q2 by R12, isn't it? Similarly, UQ3 will be equals to what? UQ3. First of all, write this expression. Since we know that UQ2, after finding in the first case, we came to know that the distance between Q1 and Q2 is R12. Since we are going to find the potential energy, after finding the potential energy, we came to know that it is 1 by 4 pi epsilon naught Q1 into Q2. The distance between Q1 and Q2 is R12, isn't it? So by finding this one, Q1 into Q2 by R12, Q1 into Q2 by R12. Similarly, we need to find for Q3. For Q3, there will be two distances, isn't it? R23 and R13. Similarly, we need to write here 1 by 4 pi epsilon naught into Q3 into Q1, Q3 into Q1 by R13. There will be plus into 1 by 4 pi epsilon naught into, similarly this one also we have written this one. Now we need to write this one, Q3 into Q2, Q3 into Q2 by R23. Now if you look here, the common term is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught and 1 by 4 pi epsilon naught, isn't it? Similarly, we can take the common. There should be plus. We can take the common. So 1 by 4 pi epsilon naught Q1 into Q2 by R12 plus Q3 into Q1 by R13 plus Q3 into Q2 by R23. Now, when the charge Q3 is placed at C, suppose this point be C, I have not written, you can write down. Suppose when the charge Q3 is placed at the point C, then it will experience two electric fields due to Q1 and Q2. So this one only we need to write. When the charge Q3 is placed at C, when the charge Q3 is placed at C, then it will experience two electric fields, that is Q1 and Q2, isn't it? So then it will experience two electric fields due to Q1 and Q2. So the potential energy of Q3, so the potential energy of Q3 will be equals to UQ3. Now, when the charge Q3 is placed at C, then it will experience two electric fields due to Q1 and Q2. So we need to find the total potential energy of Q3. You can look at the diagram carefully. When the charge Q3 is placed at the point C, then it will experience two electric fields due to Q1 and Q2. So we need to find the potential energy of Q3 now. Therefore, UQ3 will be equals to, since we know that UQ3 is equals to VQ1 plus VQ2 from the previous relation. So we can substitute the values here directly. So V means what? You can look, V means 1 by 4 pi epsilon naught into Q1 by R12. When the charge Q3 is placed here, then Q1 also will experience two electric fields, isn't it? This one also we need to remember. So here it will be VQ1 will be equals to 1 by 4 pi epsilon naught into Q1 by R13. Since this Q1 experience R13 at the point C, isn't it? R13. Since we need to find the particular case of UQ3. Here the charge Q3 is there, isn't it? So we need to look at the charge Q3. So Q3 is, that means Q1 is related to Q1 and is related to Q2, not Q1 and Q2, isn't it? So the distance between Q3 to Q1 is R13 and the distance between Q3 to Q2 is R23. So that one only we need to write here. So VQ1 is 1 by 4 pi epsilon naught into Q1 by R13 plus VQ2 is 1 by 4 pi epsilon naught into Q3 into Q2 by R23. Q3 into Q2 by R23, isn't it? The distance between them is this much and the distance between them is this much. So we have proved the relation for this topic. The potential energy of a system of two charges in an external field. This is the required solution. You can note down 1 by 4 pi epsilon naught into Q1 by R13 plus 1 by 4 pi epsilon naught into Q3 to Q2 by R23. This is the required expression for potential energy of a system of two charges in an external field. So stay tuned with the next video. We are coming soon. Please subscribe and share my channel. Thank you.